subpanel installation requires careful attention to wiring and grounding to ensure safety and code compliance. The initial observations regarding the subpanel wiring are accurate. Firstly, the feeder wire to the subpanel necessitates an insulated neutral conductor. Standard service entrance, or C, cable typically incorporates an uninsulated neutral, which is not suitable for use as a feeder to a subpanel. Secondly, a grounding conductor is essential from the main panel to the subpanel. This conductor must be installed within the same cable or raceway as the circuit conductors, meaning the hot conductors and the neutral. Thirdly, the separation of neutrals and grounds is crucial, accomplished through the use of a dedicated grounding terminal bar. This separation is a critical safety measure to mitigate the risk of accidental energization of the neutral conductor. Now, regarding the question about the number 6 spare ground wire connected from the subpanel grounding bar to a ground rod, the answer is that this configuration presents a problem. The grounding conductor originating from the main panel and terminating at the subpanel should connect to the grounding terminal bar within the subpanel. A separate grounding electrode system, which could include a ground rod, should be installed at the subpanel location to establish a local ground reference. It is important to emphasize that the subpanel grounding bar should not be directly grounded to the ground rod. This direct connection can create undesirable ground loops and potentially compromise the effectiveness of the grounding system. Addressing the recommended solutions, replacing the SC feeder cable is essential. The appropriate alternatives are firstly, a 4-conductor service entrance cable type R or SIR, which includes an insulated neutral conductor. Secondly, 4 individual THHN insulated conductors installed within a conduit system. THHN stands for thermoplastic high heat resistant nylon coated. It's a common type of insulated wire used in conduit for electrical wiring. Each of these options will provide the necessary insulated neutral and grounding conductor within the same cable or raceway as required by code. For a more comprehensive understanding, let's delve into the details of each aspect of the subpanel wiring and grounding. Starting with the insulated neutral, the National Electrical Code, or NEC, typically requires an insulated neutral conductor for feeders to subpanels. The reason for this requirement is to ensure a clear and reliable return path for current, minimizing the risk of voltage drops and potential hazards. The uninsulated neutral conductor in standard SE cable is designed for use as the service entrance conductor from the utility company's transformer to the main service panel, where the neutral is bonded to ground. However, in a subpanel application, the neutral must be isolated from ground to prevent circulating currents on the grounding system. The grounding conductor from the main panel to the subpanel serves as the primary path for fault current to return to the source, enabling the overcurrent protective device, such as a circuit breaker, to trip and clear the fault. This grounding conductor must be sized appropriately based on the size of the feeder conductors, as specified in NEC Table 250.122. The grounding conductor should be installed within the same cable or raceway as the feeder conductors to minimize impedance and ensure effective fault current carrying capability. The separation of neutrals and grounds in the subpanel is a fundamental safety principle. By isolating the neutral conductor from the equipment grounding conductors, the risk of stray current flowing on the grounding system is significantly reduced. This separation helps to prevent electrical noise and interference, and it also minimizes the potential for electric shock hazard. The grounding terminal bar in the subpanel provides a dedicated point for connecting all equipment grounding conductors, ensuring a solid and reliable ground connection for all metallic enclosures and equipment. Now, regarding the grounding electrode system at the subpanel, the NEC requires that a subpanel have a grounding electrode system if it supplies a separate building or structure. This grounding electrode system typically consists of one or more ground rods, ground plates, or other approved grounding electrodes. The purpose of the grounding electrode system is to provide a local ground reference and to help stabilize the voltage potential of the grounding system. The grounding electrode conductor, which connects the grounding terminal bar in the subpanel to the grounding electrode, must be sized appropriately based on the size of the feeder conductors, as specified in NEC Table 250.66. It is crucial to understand that the grounding electrode system at the subpanel is supplemental to the grounding conductor from the main panel. The grounding conductor from the main panel provides the primary path for fault current, while the grounding electrode system provides a local ground reference and helps to minimize voltage differences between the grounding system and the earth. Now let's consider the specific requirements for the 4-conductor SER cable and the 4 individual THHN conductors in conduit. The 4-conductor SER cable is a convenient option because it includes all the necessary conductors in a single cable assembly. The cable typically consists of 2 insulated hot conductors, an insulated neutral conductor, and a bare equipment grounding conductor. The insulated neutral conductor is identified by a white or grey colored insulation, while the equipment grounding conductor is typically bare copper. When installing SER cable, it is important to follow the manufacturer's instructions and to ensure that the cable is properly supported and protected from physical damage. 4 individual THHN conductors and conduit offer a more flexible wiring solution. THHN conductors are insulated with a tough, abrasion-resistant nylon jacket, making them suitable for installation in conduit. When using THHN conductors, it is important to select the appropriate size and type of conduit for the application. The conduit must be sized to accommodate the number and size of conductors, and it must be installed in accordance with NEC requirements. The equipment grounding conductor can be either a bare copper conductor or an insulated conductor with a green or green with yellow stripe insulation. Regardless of the wiring method chosen, it is essential to ensure that all connections are made properly and that all conductors are sized appropriately for the load. Improper wiring and grounding can lead to serious electrical hazards, including electric shock, fire, and equipment damage. Therefore, it is always recommended to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with the NEC and local codes. Here's a summary of the key points to remember. Firstly, always use an insulated neutral conductor for feeders to subpanels. Secondly, install a grounding conductor from the main panel to the subpanel within the same cable or raceway as the feeder conductors. Thirdly, separate neutrals and grounds in the subpanel using a dedicated grounding terminal bar. Fourthly, install a grounding electrode system at the subpanel if it supplies a separate building or structure. Fifthly, size all conductors and overcurrent protective devices appropriately for the load. Sixthly, follow all applicable codes and regulations, including the NEC and local codes. Seventhly, consult with a qualified electrician if you have any questions or concerns. Now, let's elaborate on the potential consequences of improper subpanel wiring and grounding. One of the most significant risks is electric shock. If the neutral conductor is not properly isolated from ground, or if the grounding system is not properly installed, a person could come into contact with energized metal parts and receive a potentially fatal electric shock. Another risk is fire. Improper wiring can cause overheating of conductors and connections, which can lead to insulation breakdown and eventually a fire. Overloaded circuits can also cause fires, so it is important to ensure that all circuits are properly sized and protected. Equipment damage is another potential consequence of improper subpanel wiring and grounding. Electrical surges and voltage fluctuations can damage sensitive electronic equipment, such as computers and appliances. Improper grounding can also cause equipment to malfunction or operate erratically. In addition to these safety and equipment-related risks, improper subpanel wiring and grounding can also lead to code violations. The NEC and local codes are designed to protect people and property from electrical hazards, and violations of these codes can result in fines, penalties, and even legal action. Therefore, it is essential to ensure that all electrical work is performed in accordance with applicable codes and regulations. To further illustrate the importance of proper subpanel wiring and grounding, let's consider a few real-world examples. In one case, a homeowner attempted to install a subpanel without properly isolating the neutral conductor from ground. As a result, stray currents flowed in the grounding system, causing electrical noise and interference. The homeowner also experienced several minor electric shocks when touching metal parts of appliances. In another case, a contractor installed a subpanel without installing a grounding electrode system. During a lightning storm, a power surge entered the building through the electrical service. The surge damaged several electronic devices and caused a fire. These examples highlight the potential consequences of improper subpanel wiring and grounding. By following the proper procedures and guidelines, you can significantly reduce the risk of electrical hazards and ensure the safety and reliability of your electrical system. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. They possess the knowledge and experience to perform the work safely and in accordance with applicable codes and regulations. Now, to expand upon the specific code references that are pertinent to subpanel wiring and grounding, it's important to note that the National Electrical Code, or NEC, is the primary standard for electrical installations in the United States. Several articles and sections within the NEC address subpanel wiring and grounding requirements. NEC Article 250, titled Grounding and Bonding, provides comprehensive requirements for grounding electrical systems. This article covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal parts. NEC Article 408, titled Switchboards, Switchgear, and Panel Boards, provides requirements for the installation and wiring of panel boards, including subpanels. This article covers topics such as overcurrent protection, conductor sizing, and neutral isolation. NEC Section 250.24, titled Grounding Service Supplied Alternating Current Systems, provides requirements for grounding the service entrance equipment. This section specifies the location of the grounding electrode conductor connection and the requirements for bonding the neutral conductor to the grounding electrode. NEC Section 250.32, titled Grounding Requirements for Separate Buildings or Structures, provides requirements for grounding subpanels that supply separate buildings or structures. This section requires the installation of a grounding electrode system at the separate building or structure. NEC Section 250.122, titled Size of Equipment Grounding Conductors, provides requirements for sizing the equipment grounding conductors for branch circuits and feeders. This section includes tables that specify the minimum size of the equipment grounding conductor based on the size of the overcurrent protective device. NEC Section 408.41, titled Grounded Conductor Terminations, provides requirements for terminating the grounded conductor neutral and panel boards. This section requires that the grounded conductor be insulated and that it be terminated on a terminal bar that is insulated from the panel board enclosure. In addition to these specific code references, there are other sections and articles within the NEC that may be relevant to subpanel wiring and grounding depending on the specific application. It is important to consult the latest edition of the NEC and to follow all applicable codes and regulations. Now, let's turn our attention to some common mistakes that are often made when wiring and grounding subpanels. One common mistake is using the wrong type of cable or conductors. As mentioned earlier, standard SC cable with an uninsulated neutral conductor is not suitable for use as a feeder to a subpanel. The correct wiring methods are 4-conductor SER cable with an insulated neutral or 4 individual THHN conductors in conduit. Another common mistake is failing to properly size the conductors and overcurrent protective devices. The conductors must be sized to carry the load, and the overcurrent protective devices must be sized to protect the conductors. If the conductors are too small or the overcurrent protective devices are too large, the circuit could overheat and cause a fire. Another common mistake is failing to properly isolate the neutral conductor from ground. The neutral conductor must be insulated and terminated on a terminal bar that is insulated from the panel board enclosure. If the neutral conductor is not properly isolated from ground, straight currents can flow on the grounding system, causing electrical noise and interference and potentially creating electric shock hazards. Another common mistake is failing to install a grounding electrode system at the subpanel if it supplies a separate building or structure. A grounding electrode system is required to provide a local ground reference and to help stabilize the voltage potential of the grounding system. Another common mistake is improperly connecting the equipment grounding conductors. All equipment grounding conductors must be connected to the grounding terminal bar in the subpanel. They should not be connected to the neutral terminal bar. Another common mistake is failing to properly tighten all connections. Loose connections can cause overheating and arcing, which can lead to fires. It is important to use a Torx screwdriver or wrench to tighten all connections to the manufacturer's specifications. By avoiding these common mistakes, you can help ensure the safety and reliability of your subpanel wiring and grounding. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Now, let's discuss some of the tools and equipment that are typically used when wiring and grounding subpanels. A voltage tester is an essential tool for verifying that circuits are de-energized before working on them. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. A wire stripper is used to remove the insulation from electrical wires without damaging the conductor. A crimping tool is used to crimp connectors onto electrical wires. A Torx screwdriver or wrench is used to tighten connections to the manufacturer's specifications. A conduit bender is used to bend conduit to the desired shape. A fish tape is used to pull wires through conduit. A drill is used to drill holes for mounting the subpanel and installing conduit. A level is used to ensure that the subpanel is installed level. A tape measure is used to measure distances and lengths. In addition to these hand tools and power tools, there are also a variety of specialized tools and equipment that may be used for specific tasks. It is important to use the right tool for the job to ensure that the work is performed safely and efficiently. Now, let's address some frequently asked questions about subpanel wiring and grounding. Question 1. What size conductor should I use for my subpanel feeder? Answer. The size of the conductors for your subpanel feeder depends on the load that the subpanel will be serving. You should consult the NEC and local codes to determine the appropriate conductor size. Question 2. What size overcurrent protective device should I use for my subpanel feeder? Answer. The size of the overcurrent protective device for your subpanel feeder should be sized to protect the conductors. You should consult the NEC and local codes to determine the appropriate overcurrent protective device size. Question 3. Do I need a grounding electrode system at my subpanel? Answer. You need a grounding electrode system at your subpanel if it supplies a separate building or structure. You should consult the NEC and local codes to determine whether a grounding electrode system is required. Question 4. Can I use the neutral conductor as the equipment grounding conductor? Answer. No, you cannot use the neutral conductor as the equipment grounding conductor in a subpanel. The neutral conductor must be insulated and isolated from ground. The equipment grounding conductor must be a separate conductor. Question 5. How do I test the grounding system in my subpanel? Answer. You can test the grounding system in your subpanel using a multimeter. You should measure the resistance between the grounding terminal bar and a known good ground, such as a metal water pipe. The resistance should be very low, typically less than 1 ohm. If you have any other questions about subpanel wiring and grounding, you should consult with a qualified electrician. Finally, let's emphasize the importance of ongoing maintenance and inspection of your subpanel wiring and grounding system. Regularly inspect your subpanel for any signs of damage, such as loose connections, corroded wires, or damaged insulation. If you notice any problems, you should have them repaired immediately by a qualified electrician. You should also test your grounding system periodically to ensure that it is still functioning properly. This can be done using a multimeter to measure the resistance between the grounding terminal bar and a known good ground. By performing regular maintenance and inspections, you can help ensure the safety and reliability of your subpanel wiring and grounding system for years to come. Remember, electrical safety is paramount, and it is always best to err on the side of caution. If you have any doubts about your ability to perform electrical work safely, you should always consult with a qualified electrician. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.